All right, number 7 is not special. So when the triangle's not special, when we don't know its angles, we always resort to Pythagorean theorem. That is where we go directly to Pythagorean theorem. I'm going to call this side A because we're going to find A first. We're not going to find X first. If we call that missing side X, then we'll think when we're done we have the final answer. We'll forget to multiply by 2. So this almost looks like a Pythagorean triple, 6, 8, 10, right? Except the 8's the hypotenuse, and so it's not a Pythagorean triple because the 10 would need to be the hypotenuse for that to work. All right, so 8 squared minus 6 squared equals A squared. We simplify the left side. 28 equals A squared. Opposite of squaring something is square rooting. And the square root of 28 is 2 root 7. Of course, the other side, it's isosceles, so those are equal. They're both 2 root 7. Are we allowed to add those? Yes, right? They're like terms. They're root 7s. And so 2 root 7 plus 2 root 7 is 4 radical 7. Number 14. 13 and 14 are very similar. They are Pythagorean theorem, which turns into Pythagorean theorem, which turns into Pythagorean theorem. Both of those have right triangles where you find a missing side of one, and that's the side of the next right triangle, and then you do Pythagorean theorem on the next right triangle. Okay? So I'm going to do 14, but 13 is really the same way. On 14, we have 1, 2, 3 right triangles. They're all right triangles, so they're all eligible for the Pythagorean theorem. It's actually beautiful because they're all Pythagorean triples. So if I do 17 squared minus 8 squared, and I don't trip over the smartboard, then we get 225, and we square root that, and that missing side is 15. And then if I do 10 squared minus 8 squared, 36, and the square root of that is 6. And now I'm doing Pythagorean theorem one more time. 15 squared plus 6 squared, 261. Oh, that one's not pretty. So you factor tree the 261 and you get 3 radical 29. These were on your last quiz when you're trying to decide if it's acute, obtuse, or right. First of all, on this one, you need to decide which one is your C. You need to find which one is your largest side. And if you don't know the square root of 34 off the top of your head, you might want to ask your calculator. It's 5.8. So that one is your C. So we always write Pythagorean theorem backwards. C squared, and then A squared plus B squared. The square root of 34 squared is 34. 3 squared plus 5 squared is 34. They are equal to each other, therefore it is a right triangle. If we had gotten less than, it would have been acute, and if we had gotten greater than, it would be obtuse. All right, number 22. Similar to the other one that involves a square, this time you're given the diagonal, which is 12. A diagonal of a square always, always, always creates 45, 45, 90 triangles because that triangle is both isosceles and right. It's isosceles. So we know we can use our rules. Remember, when you're headed towards a hypotenuse, you multiply by root 2. When you're headed away from a hypotenuse, you divide by root 2. So it's 12 divided by root 2. Rationalize. 12 root 2 over 2. 6 root 2. Final answer. Okay, last one, 23. Find the length of a side of an equilateral triangle whose altitude has length 6 root 3. I'm pretty sure we did something really similar to this in the warm-up. This is our 60, this is our 30, this is our 90. So across from 30 is 6, and across from 90 would be 12. 6, 6 root 3, 12.